All right, welcome back, guys. This week I'm going to try and see if I can get the circuit boards off to production. So I'm just going to take one last look here over my schematic. I apologize, last time I didn't record my screen at the right resolution, so it's kind of hard to see the lines and stuff. So hopefully this time will be better going forward. Here is our schematic for the 2560, which we covered last week. And we can take a look here at our USB input with the 16U2 chip attached as well. And then here is we're looking at the left frame. So this is all of our autopilot buttons right here. And then our single encoders here and here. These two guys. And then we've got our nav toggle switch, flip switch. Our dual rotary encoders there, and then our diodes as well. So I'm in KiCad. Just gonna do a last quick check here. We'll do our electrical rules check. All right, so you see we got no errors, no warnings. That's good. We'll flip over to our PCB here, and if we take a look at this, right now we're looking at just the front layers. I'm gonna switch over here and show all layers. You can see when I do this, we get the drawings that I put in. So I work on the design, the 3D design for the parts that I'm going to 3D print. And then I'll take an outline of the basic design of that, and I'll bring it into here as a drawing or a DXF file or something like that. And then that kind of gives me a rough idea of where all my holes and buttons and things need to go. And I use this outline as I start developing the PC board. That's going to go into this thing. So here you can see I've got it lined up, and the reason why I have two is because when I flip to just the back layers, let me turn on the drawing, you can see everything's lined up here. So if I'm looking at the back layers, I still want to see how it sits in context with the rest of the G1000. So that's why I have two different frames in here. One's for the back layer, and when I flip to the front layers, let me turn on the drawings again. Then it's all over here on the right side. So it's just a matter of convenience when I'm working on the PCB, front or back side only. Just lets me know where everything is in relation to each other. So here's our layout. We've got all our encoders and everything ready to go. So I'm just going to do another quick design rule check. That I've got a couple of screw holes here that are overlapping the Courtyard for this bottom encoder. This is the altitude encoder on the left side, just below all these autopilot buttons. And you can see that I've got these two holes here and here are going to be PCB mounting holes, and then this hole is going to pass through the PCB just to allow for panel mounting. So this one just needs to go straight through the circuit board. It doesn't actually connect to anything or touch anything. So this will be a non-plated hole. And you can see there's this additional outline around it. And the outline for this hole overlaps the outline for this encoder. But I actually know for a fact that the encoder, the shape of the encoder itself is actually this yellow box right here. So this Courtyard is just to let you know, hey, if anything encroaches in this or overlaps, you could have issues, and it's just like nice to keep things out of that Courtyard. I don't know if there's anything more specific than that. That's just my understanding of it. So I could be wrong. But the physical shape of the encoder is this yellow box right here. So I know as long as I'm away from that yellow box, I should be fine. And these screw holes aren't the size of the pink circle. They're not that size. They're the size of the blue circle in here. So I'm not going to have a screw head right here. This is just a screw passing through a hole right here. So I know nothing's going to interfere right here. In fact, I know these are pretty close together. The outline here to the outline of this pad. But that doesn't matter because I don't have a screw head sitting here that's going to encroach in this Courtyard. This one I will, but it's going to be fine because I know that the physical component goes to this edge. And so if a screw head fits inside this Courtyard, overlaps in here, it's not going to be an issue. Same with this one, not going to be an issue. So those are most of my errors right there, the only 3 errors I have, I'm going to go ahead and just exclude. In fact, let's exclude all of them. There we go. So now if we just take a look at the warnings, we got 10 warnings. We'll just kind of scroll through this and see if we've got anything major or anything serious. It doesn't look like it. It's just like silk screens are overlapping now. So we'll just go take a look at these and see where they are. Looks like this one might be, I'm not sure if this is front or back. Let's go to all layers. If you look here, we've got our yellow arrows right here. So we will take a look at the back side. Looks like that's where it is. And sure enough, yeah, this is our text that gets silk screened. I'm going to go ahead and move this. Let's see. I don't know where I want it. This is for diode 2. Looks like it's this one right here. I'm going to go ahead and shrink the size of this as well. Let me get this ERC box out of the way. So I like to come in here. I like to make sure that my text is about 1 millimeter width and 1 millimeter height and a thickness of about 1.15. I find like that's a pretty good size for what I'm doing. You could probably go smaller than that if you want, but that seems to work out okay for me. So we'll just make sure those labels aren't overlapping any of their pads. So it looks like that one should be fine. We got this D7 here. That looks like that might be on the front layer. So we'll come take a look here. D7, you can see it is overlapping the pads for the resistor above it. So we'll just move that down a little bit. And then again, I'll just check the size. Yeah, I'm good with that one. That should be fine. So now we'll just keep working through all of these errors and warnings, and I'll just make sure they're all resolved. All right, let's go ahead and save this. Let's run our DRC again. And you can see we got no warnings, no errors. Everything looks good there. So I'm going to close this window. All right, next thing I'm going to do is look at our 3D file here. So you can see we've got our files. We're missing some 3D components. We're missing the dual rotary encoders here, and a bunch of these switches don't have the 3D file associated with them. So that's fine. We know all the rest of the design is good. We could send this off to be manufactured right now, but I actually like having the 3D models in here, and I don't need it on everything. Like a lot of the resistors and LEDs up here. Well, let me zoom in a little bit. It might be easier to see. So a lot of these little, resistors and LEDs, it's not a big deal whether the 3D models are in there or not, but I do like having the encoders and the buttons. Let's see, let's get down to where these buttons are. So the encoders are nice to have. The buttons are also nice to have on there. Anything that's kind of bigger that might have some interference due to its size or position or something like that, I definitely want those in there, and I'll show you why in a minute. Let me resolve all these real quick. So let me go back to my PCB and I'll get those updated real quick. Now we've got our encoders in there. Looks like they're all positioned in the right place as well. We flip over here to the back side. You can see here we've got our 2 chips, our 2560 and our 16U2 chip. I don't have the USB connector right here. I might go ahead and add that. I don't have 3D files for the 2 connectors. And this guy right here would be our multiplexer. I don't have a 3D file for that as well. Like I said, it's not necessary. I like to have them. So that's our 3D design. It's looking pretty good. So I think we're good there. Let me show you why I actually like having as many of the big parts as I can on the 3D models. here I have, it's a 3D printed version of that 3D circuit board file. So I actually like to use these to validate the shape and fit and function of my PCBs. Obviously I can do it in the software, sure, but it's kind of nice just to have something printed out that I can, like, you know, a physical product that I can interact with and stuff. You can see I'm missing an encoder here and the one down here. I actually accidentally ripped them off when I was ripping off the supports for those. This is actually the right frame PCB. And then what I do is I print out my right frame that I'm going to actually print as I'm testing this to make sure everything fits and all nice and stuff. This is the mounting hole for this frame, and it passes through to the back right here. So that's that one. We got some more PCB mounting holes down here. I know it's like probably out of focus or hard to see, but it's just nice to validate the design and make sure like everything's going to fit. I did have a problem in the beginning where these standoffs, I guess they're screw bosses, I should probably say, for the PCB, where the PCB is going to screw in, like these holes right here. I had them too low down in, and so the circuit board was actually not going to fit in there right. It was they were too far down, and so the circuit board wouldn't actually rest on those screw bosses. So that was one thing I discovered after printing these out physically. It might be an unnecessary step, but it's something I like to do just to make it a little easier to validate. All right, so now let's go back into KiCad and let's get this thing ready for production. Okay, took me a few days to get some things resolved here. I had some problems with my footprint libraries and some of my symbols in KiCad here. So I think I've got everything working right now and updated. So we're going to take a look here. This is the right frame. Actually, let's go to the left frame real quick. That's the PCB. Okay, the left frame. Here we go. Let's zoom in here. Make sure everybody can see this. This is our big connector, our 36 pin connector. Pin 1 goes to the COM volume encoder, and then let's see, pin 35 is power, pin 36 is ground. So on the left frame that's going to connect to this, it's going to be inverted. So pin 36 would be COM volume A, pin 1 would be ground. So let's just quickly verify that on our schematic here. So here it is. I know this is oriented a little differently, but we're just concerned about the pin numbers right now. So COM volume A, pin 36, and ground is pin 1, power pin 2. So looks like those two are correct. Let's just go back here and verify. Yeah, pin 1, ground, okay. And then let's verify on our circuit boards. So here's the left frame. This is the 36 pin connector right here. If we zoom really far in, you can see our pin numbers. Pin 1, this is D2. So the labels are different, but this is going to the same thing. This is going to the ATmega 2560 chip, which would be the digital pin 2 in an Arduino. So that would be our COM A, that's pin 1, and then ground here is pin 36. That matches our schematic. So now if we go look at the right frame PCB, it should be opposite. So here pin 1 is now ground. Let's go back to that other one. Pin 36 is ground there. Pin 1 is ground on this connector, because this connector faces the other connector on the opposite side. So, and just to verify here, zoom in here, COM volume A is pin 36. So those are correct. If you want to see the whole thing in context again, there we go. All right, let's go take a look at the back schematic. Actually, first, let's go look back at the our main board here is kind of how I consider this left side frame, because it has the Arduino on it. It's the main board, basically. So here is the small connector that's going to go to all the soft keys on the bottom frame, all the bottom buttons of the G1000. You can see pin 1 is soft key 1, pin 12, soft key 12, ground is pin 14, and power right next to it, pin 13. So this is on the left frame, the Arduino board. And then if we go look at the schematic for the bottom board, you can see that we've got it all switched up. So now soft key 1 is now pin 14, 12 is pin 3, then we have ground and power. So that's correct. Let's go verify our circuit boards. Here's our left frame. Let's zoom in on the small connector here. Whoa, a little too far there. All right, pin 1, soft key 1, pin 14 is ground. So it should be flipped on this board. So here's our bottom frame. Let's just look at the back layer so we can see the connector here. All right, here's our connector. Pin 14 is soft key 1, pin 1 is ground. So those are correct. Those connectors should be wired opposite of one another because they face each other, like I talked about in one of the previous videos. So there we go. We are good to go. We're going to go ahead and export all the files for these. So I'm going to click my fabrication toolkit button here, and let me bring this window over to this monitor. So this is going to go ahead and just make sure all my settings are good there. I'm going to click generate. It's going to pop open another window asking me where I want to save them. So this is the bottom frame. I have this production folder, and that's where it's going to put all those files. You can see I got this nice bottom frame zip file, and that has all your drill files and Gerber files, whatever it is. All the stuff that they need for PCB fabrication is just going to be right there in that zip file, which is really nice. You got your CSV for your bill of materials, some more positioning, designators, all these other additional files that you might need. It's nice to have. So it's nice that I can just click one button, boom, it's all exported, everything I need right there in one file. So I'm going to go ahead and do that for, let's save that. Let's go ahead and do that for the left frame now. So we'll generate those files. It's going to show us, it's going to show us here in my left frame in the production folder, there's all my new files. Pretty slick. All right, so we'll save that one. Then we will come to our right frame, which is the last of the PCBs. Go ahead and generate that. And now we're in the right frame. It created a production folder with all my files in there. Pretty sweet. So let's move this out of the way. I'm going to go ahead and close this as well. And close up KiCad. All right, now let's go to my browser. All right, so here we are. This is JLCPCB's website. If you've never ordered stuff from them, it's pretty simple. You can just click on, I come down here to quote now, 1 to 4 layers. My left and right boards are 4-layer boards. So I don't even have to select anything here. I can just add the Gerber file. So I can come in here to my project. And I'm going to start with the left frame. So here in my production, I can select the zipped file. I open that, and as it uploads, it's going to detect the number of layers and everything for me, so I don't have to come in here and select any of this. And it'll give me a preview of the circuit board here as well. So you can see it detected. We got a 4-layer board. It's got our dimensions on there. The minimum quantity we can order is 5. Since this is a prototype, I'm not going to do any more than that. I'm just validating that the design works and that I can get everything fitting correctly with my my 3D printed frames. I like black, so I'm gonna go ahead and go with black. Let's see what the price difference is there. So you can see for green circuit boards, they're the cheapest option, usually $26.80 for 5 of these. It's pretty sweet deal. I like the black ones. I just like the look of them, so I'm gonna go with that. They're a little bit more expensive, but not much. Like, what is that, $6, $7? It's not bad. Silkscreen, all the rest of these settings I leave as they are. So I'm just going to leave that at the default. 1 ounce copper weight's fine. The rest of this stuff I just leave as default because I don't really need anything extra. I am not going to do PCB assembly. If I do that, then I have to go and source all the parts and get JLCPCB to purchase all the parts, get all the quantities in, and then they can do the assembly. I've never actually used their assembly. I'm just going to do this by hand because these are prototype boards. So I'm going to go ahead and create stencils though for all of these. So I like the frame around the stencil. I don't know what step stencil is. I just am going to leave that. I'm going to do top and bottom on the same stencil. That's fine for me. I don't care if their logo shows. I don't need any remarks for the stencils. So we will add that to our cart. Okay, and then now I can add another Gerber file. So I'm going to go ahead and grab my right frame in my production folder. There's the zip. So again, it's just going to upload. It's going to detect how many layers this board is. So I don't have to worry about any of that. Oh, this is the bottom frame. I thought I did the right frame. Doesn't matter. Everything's correct. We got our dimensions, our layers. I'm going to go ahead and go black again. Oh, there's actually no price difference on that one. And I'm going to create a stencil for this as well. I probably don't really need a stencil for this one, but I like to have them. It just makes putting your solder paste on so much quicker and easier. So go ahead and add that. And now let's make sure we get the right frame. Oops. Let's grab the zip file. Here we go. All right, there we go. Another 4-layer board. And let's go ahead and go black again. Could also do white because it would reflect more light if I was worried about that, but I'm not. So we're going to stick with black. We'll keep all our stencil options the same. All right, we'll go ahead and save that. And we've got our 3 circuit boards with their stencils as well. The stencils are always an additional $7, so it's not too bad. All right, so we select everything. We're good with that. We'll go ahead and check out. All right, here we go. We've got our 3 circuit boards, got our bottom frame, got our left frame, we got our right frame, we got a stencil for the right frame, the bottom frame, and the left frame. So there's everything. All right, that's it. So now we're good. We just wait. Now we wait patiently. All right, so that's it for this one. We'll see you in the next one.